Hello everyone, good morning. Today's topic is acceleration. In the last topic we did about velocities, speed. Now we are going to do about acceleration. Acceleration is the rate of change of velocity. It is denoted by this formula where V denotes the final velocity, U denotes the initial velocity and T denotes the time period. Now what is the SI unit? The SI unit of acceleration is meter per second square and it is again a vector quantity. That is, it has magnitude as well as direction. Now, suppose if any object is moving with an initial velocity of 5 meter per second, after a time period of suppose 10 seconds, it moves with a final velocity of 15 meter per second. What is the acceleration? The acceleration is 15 minus 5 divided by 10, which is equal to 10 upon 10, which is equal to 1 meter per second square. It is accelerating at 1 meter per second square. But if the final velocity is less than the initial velocity, I'll give you an example. Initial speed is again 5 meter per second. Final speed comes at final speed comes at 4 meter per second at a time period again of 10 seconds. Now what is the acceleration? We'll put the values. It is 4 minus 5 upon 10, which comes out to be minus 1 upon 10 meter per second. This means, or we can write it as minus 0.1 meter per second square. This denotes that the object is retarding because its final velocity is less than the initial velocity. First equation of motion is V is equal to U plus AT, which means the final velocity. We can find out the final velocity if we are given with the initial velocity. If an object is accelerating at a constant speed, a uniform acceleration at a time period. I'll tell you how to denote this equation. First of all, we know acceleration is equal to final velocity minus initial velocity upon time period. We'll cross multiply this equation. We get AT is equal to V minus U. Or in other sense, we can use V minus U is equal to AT. So V is equal to U plus AT. This denotes that if we are given any of these, there are 1, 2, 3, 4 things. Final velocity, initial velocity, acceleration and the time period. If three of them are given, then we can take out the fourth unit. And this implies only to those objects which are accelerating at a uniform speed. Now it is the second equation of motion, which says that S is equal to ut plus half at square, where S denotes the distance, U initial velocity, time period, A is acceleration and T is the time period. It denotes that if we are given the initial velocity and we know the acceleration and the time period, we can take out the distance traveled by an object. Now we'll see how to derive it. We know the average velocity is equal to V plus U upon T. And different initials and the final velocity added and divided by 2. This gives the average velocity. We know the distance is equal to average velocity into time. So we can write it here, V plus U upon 2 into time. As we know from the first motion of equation, V is equal. So on adding this, we get 2U plus AT upon 2 into T. Now multiplying T on both the sides, I'll continue it here. It comes out to be 2US is equal to 2UT plus AT square upon 2. Cross multiplying it again, we get 2S is equal to 2UT plus AT square. So S is when we divide both of them by 2, we get S2 gets cancelled. We get S is equal to UT plus half AT square. Hence the second equation of motion is derived. S is equal distance is equal to UT plus half AT square. Thank you so much. In the next lecture, we'll do the third equation of motion. Bye. Take care.